So, for lack of a better phrase, translation is just sliding a shape horizontally and or vertically. So, like right here, we have ABC, the pre-image. We just kind of slide it over here, and see how it's facing exactly the same direction. Everything looks pretty much the same, except we just took it and shoved it over there. There was no rotation, no reflection, nothing. So, let's look at what translation's actually taking place here. So in order to do this, we have to match up corresponding points. And I'll do point A. Feels nice. Why not? Let's do A. So A goes over this amount and then up this amount. Or up and then over, either way. So what we have to do, we have to count that. So we have 18 to the right, and then 4 up. So the way we would write this translation is capital T, and then we do the x-axis amount first, and 18 is positive because positive goes right, and then 4 for the vertical change. Now, this next question says, what do you notice about the vectors between corresponding points? So first, let's draw the vectors between corresponding points. These vectors show the distance and direction. So like from A to A prime, from C to C prime, and from B to B prime. It shows the direction that the translation actually goes, and you have an arrow to determine which direction that goes. Now what you should notice about these vectors, and forgive the drawing, they're not absolutely perfect, but they're decent, you'll get the idea. These vectors are all parallel to one another. And that's always true in a translation. If you have any corresponding points, the vectors between the corresponding points, these vectors have to be parallel to each other. And it could be any point on the figure too. We could even take like this point right here, which corresponds to roughly kind of this point right here. That vector between those two would also be parallel to the original vectors as well. Just wanted to take this opportunity to remind you guys about the notation for these things. So we're going to look at the rigid motion specifically. We'll save dilations for later, but reflections, rotations, and translations. Now, reflections are a lowercase r, and then in subscript below you have the line of reflection. So right here, if this says lowercase r and then below it y equals x, that's a reflection over the line y equals x. Rotations are capital R's, and they have the number of degrees, and then the center, if it's not the origin. If the center is the origin, which is probably the most common one you guys are going to see, then you just won't even see a point. You'll just see like R180, and this won't even be here. No 20, nothing like that. But in this case, what it means is we're taking a rotation of 180 degrees around the point 20. And since this direction, or since this degree number is positive, that means we're assuming that it goes counterclockwise. If the degrees were negative, we would assume it goes clockwise. And finally, translations. We just talked about it a little bit. We have a capital T, and then we have the change in the x, the left-right distance, and the change in the y, the up-down distance. And left is going to be negative in this regard, right is positive, and up is positive, down is negative. It's just like you would expect on a coordinate grid. So for example, in this case, t negative 9, 3 means you go 9 units left and 3 units up.